Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to be discussing word problems with inequalities. More specifically, we're going to work out 7 practice problems. As always, it's a good idea to read each problem yourself, pause the video, attempt to work out the problem yourself, and then resume playing the video to see if you and I came up with the same solutions in the same way. To recap things before I get started, I want to mention that solving inequalities is almost the same as solving equations. The key difference being that equations have equal signs, whereas inequalities make use of inequality signs. As you can see, you're going to be using these 4 over here, that is less than, greater than, less than or equal to, or greater than or equal to. Similarly, I also want to remind you that one of the other differences is when you multiply or divide by a negative across the inequality sign, that is on both sides of the inequality sign, that's going to prompt you to flip the direction of the inequality. And we'll see that in just a few minutes. Similarly, I also want to mention that this video contains some problems in which you're going to have to do multiplication and division with decimals and fractions. Again, if I just gave you easy problems in this video, it really wouldn't help you prepare for either the mathematics knowledge or arithmetic reasoning subtest of the ASVAB, given that you're not allowed to use a calculator on either of those 2 subtests. So if you watch this video, you're going to get a good refresher as to how to work with decimals and fractions again. So all that said, let's go ahead and get started with today's video. Question 1 says, Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 at the end of the summer. He withdraws $25 per week for food, clothing, and movie tickets. How many weeks can Keith withdraw money from his account? Okay, so the directions actually give us a clue as to how to start these problems. It says establish a variable, write an inequality to represent the scenario, and solve. So in this case, let's start by establishing a variable. We're told for this problem he withdraws $25 per week. So we can go ahead and use the variable W to represent that amount. And again, you could have let that be any variable that you want. W just makes logical sense. And similarly, we're told that he starts out with $500 at the beginning of summer. So to represent how much he's losing each week, we're going to write the equation 500 minus 25W. Again, this says he starts with $500. Every week he loses this amount or spends that amount. That said, we still have to write the other half of this inequality. And I'm going to put a box right here to figure out which inequality sign we're going to use. But that said, we're also told he wants to have at least $200 left by the end of summer. So that gives us a clue as to which inequality sign we're going to use. Again, he wants to have at least $200. So he can have $200 in his account, which means we're either going to use less than or equal to sign or the greater than or equal to sign in the box. Let's see what's going on here, and then we'll decide which of these 2 to use. This says that he wants to have this amount in his account, and it's got to be greater than or equal to $200. So in other words, the amount he's left with in his account has to be greater than or equal to $200 at the end of summer. So we're going to go with greater than or equal to. And at the end, we'll graph this on a number line to see why it makes sense. But that said, now we have identified a variable as written in inequality to represent the word problem. Let's go ahead and solve the inequality. And before we do that, let's rewrite this without the box there so that we can work with this equation a little more. So again, we're solving for the variable w. The first thing we're going to do is subtract 500 from both sides. And that's going to cross these out. 200 minus 500 is negative 300. Again, that's less than or equal to negative 25. W, again, we're trying to get w by itself. So we're going to divide both sides by negative 25. And again, since we're dividing across the inequality by a negative sign, that's going to prompt us to change the direction of this sign from less than or equal to greater than or equal to. So make sure to keep that in mind. This crosses out, leaving us simply with w on this side of the equation. And now we have negative 300 divided by negative 25. Well, 25 times 4 will give you 100. 25 times 8 will give you 200. 25 times 12 will give you 300. So we know this is going to be 12. Again, a negative divided by a negative is going to be a positive. So if we rewrite this with the variable on the left, we can see w is less than or equal to 12. And again, that says, in other words, he can go no more than 12 weeks withdrawing money from his account. And if we were to put that on a number line, that would look like this. Let's put 12 right here. I don't know why I put negatives there. Those are positive. Sorry about that. Again, w is less than or equal to 12. So we're going to put an open circle or a closed circle above 12. And then w is all the values less than 12. So the arrow is going to go to the left. What this means is that in this case, Keith can withdraw money, the $25 a week, for up to 12 weeks before he has $200 left in his account. Okay, so that was this one. Again, these word problems are not very easy to do. That said, the more of them you do now, the easier they'll be when you take the ASVAB. So that was this one. All right, number 3 says a taxi charges a flat rate of $1.75 plus an additional 65 cents per mile. If Erica has at most $10 to spend on the cab ride, how far could she travel? So again, let's first start by writing in our variable, 65 cents per mile. So let's call that M. Again, you could have put whatever you want there. We know similarly that the cost of the trip, regardless of how far she goes, is going to be $1.75. And again, for every mile, she's going to be charged an additional 0.65 cents. So we've written the right-hand side of this inequality. That said, we still have to come up with what inequality sign we're going to use. And similarly, we have to know what's on this left-hand side. We're told simply that she has $10 to spend, so we know that 10 is going to go over here. Now, in this case, she can spend up to $10, including $10 on the cab ride. So we know we're going to either use less than or equal to or greater than or equal to. If you think about this, this is the amount she's spending on the cab ride, which can be no more than $10. So this amount has to be less than or equal to $10. Okay? So we're going to use this symbol. Now, to solve this problem, it's a matter of solving for m. And let's go ahead and rewrite the equation before we proceed. And again, the first thing we're going to do is subtract 1.75 from both sides. This is going to cross out. And on this side of the equation, we're going to be left with 0.65. M is less than or equal to 10 minus 1.75. In case you haven't done subtraction with decimals in a long time, this is how you do it. You write 10 in decimal form, which is 10.00, and we're going to subtract 1.75 from 10. In this case, we would start by saying 0 minus 5, which we can't do. That would prompt us to borrow from the next number over. Since that's 0, we can't borrow, so we have to go to the next number over. Can't borrow since that's 0, so we're going to have to borrow all the way over here. This is going to become 9. This is going to become 10. Again, we still can't borrow to do this 0 minus 5, so we have to borrow one more time. This becomes 9. Now this becomes 10. Now we can actually borrow from the number to the left. So this is going to become 9, and this is going to become 10. And we can proceed with the subtraction. 10 minus 5 is going to be 5. 9 minus 7 is 2. When you do subtraction with decimals, you simply drop the decimal place where it stands, so it's right there. 9 minus 1 is 8, and this becomes 0, not 9. Sorry about that. 0 minus 0 is nothing, so we can see 10 minus $1.75 is $8.25. So in other words, that goes here. And now we have the equation $8.25 is greater than or equal to 0.65 m. Again, we're trying to solve for m, so we're going to divide both sides by 0.65. This crosses out, leaving us with this equation. M is less than or equal to 825 divided by 0.65. Again, you can regard all fractions as long division by rewriting them like this. 825 divided by 0.65. Now, in case you haven't seen this in a while, there are some rules with which you need to be familiar in terms of doing long division involving decimals. First, you need to be mindful of the fact that you can proceed as normal if there are no fractions outside the division bracket. If, however, there are decimals outside the division bracket, you have to shift those decimal places such that you make that number outside the division bracket a whole number. And then similarly, you have to shift the number inside the division bracket, the decimal inside the division bracket, a corresponding number of times. In this case, 0.65 is outside the division bracket, so we're going to shift its decimal twice to make 0.65 65. And as I just mentioned, we're going to have to shift this decimal corresponding number of times, so 1, 2. In other words, this problem is 825 divided by 65. And now we have a simple long division problem that we can go ahead and get started on. 65 goes into 8. 8's too small, so we can't do that. 65 goes into 82 one time without going over. Again, 65 times 2 would be 130, which is too big, so we can only do 1 there. 65 times 1 is 65. Let's subtract this out. 2 minus 5 we can't do, so we have to borrow. This becomes 7. This becomes 12. 12 minus 5 is 7. 7 minus 6 is 1. And we're going to go ahead and drop down this 5. Now the question is, how many times does 65 go into 175 without going over? Well, 60 times 3 would give you 180. Therefore, we know 65 times 3 is going to be bigger than 180. So we know this is going to be 2 times. Let's go ahead and work that out. 65 times 2. In case we can't do it in our head. 5 times 2 is 10. Carry the 1. 6 times 2 is 12 plus 1 is 13. So in other words, 65 times 2 is 130. Subtract. 0 minus 5 is 5. 7 minus 3 is 4. 1 minus 1 is nothing. Now the question is, how many times does 65 go into 45? It doesn't, so we have to add a 0. And in doing so, that's going to prompt us to put this decimal place up there. Now the question is, how many times does 65 go into 450 without going over? And this one's going to be tougher because 60 or 6 times 7 would be 420. 60 times 7 would be 420. So I'm going to say this is going to be about 6 or 7 times. Let's go ahead and start with 7 and see what that comes up, what that gives us. 65 times 7. 7 times 5 is 35. Carry the 3. 7 times 6 is 42, 43, 44, 45. And as we can see, this is bigger than 450, which means we can't use 7 in this case. So we're going to have to do 65 times 6. 5 times 6 is 30. Carry the 3. 6 times 6 is 36, 37, 38, 39. So in other words, 6 times 65 is 390. Let's subtract that out. And we're going to work this out to one more decimal place so we can round the answer. And on the ASVAB, you're going to more often than not have to do that. 0 minus 0 is 0. 5 minus 9 we can't do. We have to borrow. This becomes 3. This becomes 15. 15 minus 9 is 6. Okay. 3 minus 3 is nothing. Again, 65 doesn't go into 60, but we have a 0 we're dropping down. Now the question is, how many times does 65 go into 600? Well, 65 times 10 would give you 650. So this is either going to be 9 or 8. So again, without doing the work, we know this is 9 or 8, which means that we can round up this 0.6 to 12.7. And if we rewrite this to put the variable on the left, we can see that, in other words, with the $10 that she has and the rate of the taxi fare, she can travel no more than 12.7 miles. All right, number 3 says Chris wants to order DVDs over the internet. Each DVD costs $15.99, and shipping the entire order costs $9.99. If he can spend no more than $100, how many DVDs could he buy? So in this case, we have to realize that he can spend up to $100, including $100. So in other words, we're either going to use less than or equal to or greater than or equal to as our inequality sign. Let's start writing the right-hand side of the equation. And again, the $15.99 represents the cost per DVD. So we'll call that variable D, where D represents the cost per DVD. Again, we know shipping's going to cost $9.99 regardless of how many DVDs he orders. So this is going to be $9.99 plus $15.99 D. Again, in this box, we got to decide which inequality sign to use. But that said, we know he can spend at most $100. So what this right-hand side of the equation says is this is the amount he can spend. As we know, that has to be less than or equal to $100 since that's all he has. So let's go ahead and rewrite this without the box in it. Again, this is greater than or equal to $9.99 plus $15.99 D. Again, we are treating this like an equation insofar as we're trying to get D by itself. So to start, we're going to subtract $9.99 from both sides. So that's going to prompt us to cross this out. since 999 minus 999 is 0. And that's going to leave us with this on this side of the equation, 1599D is less than or equal to 100 minus 999. In case you can't do that in your head, it's a good idea to practice doing your arithmetic. So let's write 100 in decimal form. That's 100.00. And again, we're subtracting 999 from that. So we're going to line up our decimals. Subtraction with decimals is pretty straightforward. You drop down your decimal place as it stands, and then you do the subtraction accordingly. 0 minus 9 we can't do, so we have to borrow to the left. We have a 0 here, so there's nothing to borrow. We have a 0 here, so there's nothing to borrow. We have a 0 here, so there's nothing to borrow. So we're going to have to borrow all the way over here. This is going to become 0, and this is going to become 10. Again, we're trying to borrow all the way over here, so we're going to have to borrow across all these places. So this is going to become 9, and now this is going to become 10. This is going to become 9. This is going to become 10. And finally, this is going to become 9, and this one's going to become 10. Now we have 10 minus 9, which is just 1. 9 minus 9, which is 0. 9 minus 9, which is 0. And then 9 minus nothing, which is 9. So in other words, this is going to be 90.01. Again, we're trying to solve for D, the number of DVDs he can purchase. So we're going to have to subtract as our next step. We're going to have to divide as our next step 1599 to both sides. And of course, this is going to cross out, leaving us with this. D on this side is less than or equal to 90.91 divided by 1599. Again, all fractions can be regarded as long division. So we have, in other words, 90.01 divided by 1599. Again, we're doing division involving decimals, including with a decimal outside the division bracket. So that's going to prompt us to shift its decimal place to make this number outside the division bracket a whole number. So we're going to have to shift that 2 times, and what we do outside the division bracket, we're going to have to do inside the division bracket a corresponding number of times. So in other words, we're going to be working on this problem, 9,001 divided by 1,599. And on the ASVAB, you are going to see questions in which you're going to have to do division like this. So just be prepared for it. It's better to see it now than later, because now you can actually work on it and make mistakes without being penalized for it. But that said, let's go ahead and start working on this long division. So let's get started. 1599 goes into 9,001 how many times without going over? It's going to be between 4 and 6 times. 6 times 2,000 would be 12,000, whereas 4 times 2,000 would be 8,000. So we know this number has to be between 4 and 6. Let's go ahead and start with 5, the number right in the middle. So we're going to do 1599 times 5. 5 times 9, of course, is 45. So 5 goes here. We carry the 4. 9 times 5 is 45, plus 4 is 49. Again, carry your 4. 5 times 5 is 25, plus 4 is 29. Carry the 2. 5 times 1 is 5, plus 2 is 7. And as we can see, if we were to add 1599 to this, it would get us above 9,001. So we're going to go ahead and say this is 5. But just to show you that, let's do 1599 times 6, just so you can see what I'm talking about. 9 times 6 is 54. 9 times 6 is 54, plus 5 is 59. 5 times 6 is 30, plus 5 is 35. 6 times 1 is 6, plus 9 is 9. So we can see this is 9,594, which is bigger than 9,001, so we couldn't use 6. So let's go ahead and get rid of that now that we've seen it. Okay. So again, we said this was 5. Let me get rid of that real quick. 5 times 1599, as we just worked out, is 7,995. Let's subtract. Again, in this case, we have to do some borrowing since we're doing 1 minus 5. That said, we have 2 zeros, so we know we're going to borrow all the way over here. This is going to go from 9 to 8. This one's going to become 10. We have to borrow again. This becomes 9. This becomes 10. And finally, this becomes 9. And this becomes 11. 11 minus 5 is going to be 7. 9 minus 9 is 0. 9 minus 9 is 0. And then 8 minus 7 is 1. And again, now the question is, how many times does 1599 go into 1007? It doesn't, so we have to add another 0. By adding that 0, that's going to prompt us to put a decimal there. And in this case, we're not going to work out this decimal place. We're going to represent it as x, because that means that it's going to be 5 point something. So in other words, this is going to be 5 point x. And if we rewrite this like this, d is less than or equal to 5 point x. What this means is he can only order 5 point something DVDs. In other words, just 5 DVDs before he spends $100. Again, you can't buy a part of a DVD. You can't buy half of a disc. So we know that this answer is going to be just 5. Okay? Again, pretty challenging problem, especially here where you had to use some logic to answer this one. The rest of them in this video are going to get a little easier. But that said, it's good to review how to work with decimals. All right, question 4 says, Allison practices her violin for at least 12 hours per week. She practices for 3/4 of an hour each session. If Allison has already practiced 3 hours this week, how many more sessions remain for her to meet or exceed her practice goal? So again, let's start by deciding what inequality we're going to use. It says meet or exceed. That means we're either going to be using greater than or equal to or less than or equal to. And now let's start to write the right-hand side of our equation. Again, she practices 3/4 of an hour per session, and I'm going to call that practice session just X. And we're told, in addition, that she already practiced 3 hours this week, so we're going to put a +3 there. Again, we have to decide what inequality of the two we've decided to use we're going to put in the box. And again, we're told she practices her violin for at least 12 hours per week. Now, this is the amount of practice she does per week, and we want this to meet or exceed 12. So in other words, this side of the equation is going to be greater than or equal to 12. With that equation written, or with that inequality written, we can go ahead and start solving. First thing I'm going to do is rewrite this without the box so we can start solving it. Again, this is 3/4 x plus 3. So let's go ahead and try to get x by itself, starting by subtracting 3 from both sides. This crosses out, leaving us with 12 minus 3, which is 9, is less than or equal to 3 over 4x. Now we're solving for x, so to get x by itself, we're going to multiply 3/4 by its reciprocal, namely 4 over 3, and we're going to do that to both sides. This is going to simply cross out this 3/4, leaving us with just x is greater than or equal to 9 times 4 over 3. That is, we have 9 times 4 over 3. We have a whole number times a fraction. In case you haven't done this in a while, we can rewrite 9 as a fraction by simply placing it over 1, which will allow us to do this pretty quickly. And now we're doing multiplication with two fractions, in which case you multiply straight across. That is, you do 9 times 4 over 3 times 1. 9 times 4 is 36 over 3 times 1, which is 3. 36 divided by 3 is 3 goes into 3 one time, 3 goes into 6 two times. Therefore, we know 9 times 4 over 3 is going to be 12. If we rewrite this with the variable on the right, the x is greater than or equal to 12. And that came out bad. So let's rewrite it. In other words, this x refers to her practice sessions. She needs to practice at least 12 more times to exceed her goal of practicing 12 hours per week. Okay, so that was that one. Again, some multiplication with fractions, which is a good review. All right, number 5 says Pet Supplies makes a profit of $5.50 per bag on its line of natural dog food. If the store wants to make a profit of no less than $5,225, how many bags of dog food does it need to sell? So no less than means we're going to, you can profit $5,225 or more. So right away, we need to know that we're working with greater than or equal to or less than or equal to. That said, let's start writing this equation. And again, we're trying to figure out how many bags of dog food it needs to sell, and its profit is $5.50 per bag. So we'll call this one B for profit per bag. So to write the right-hand side of the equation, we know it's going to be 550 B, and that's all the information we're given. It makes $5.50 a bag, so we're going to have to put our box there to try to figure out which of those two inequality signs we're going to put in there. And again, the profit has to be $5,225. And in this problem, it says the profit, which we represented as $5.50 per bag, has to be greater than or equal to 5,225. So we're going to use the greater than or equal to, or the less than or equal to sign there. So let's go ahead and solve this one. This one, fortunately enough, is pretty straightforward, given that it's a one-step equation. To get b by itself, we're going to divide both sides by 550. This is going to cross out, leaving us with just b. And now we have 5,225 divided by 550. So let's do the long division. Now, to make this easier, we can disregard this 0. So this will just be 5.5. Again, that's the same thing. That said, we're doing division, including with a decimal that's outside the division bracket. So we're going to have to shift this decimal place one time. And what we do outside the division bracket, we have to do inside the division bracket a corresponding number of times. The decimal is technically right here in 5,225. So we're going to shift it one more time and add a 0 in accordingly. So in reality, we're doing this problem, 5,220. Well, this is going to be 52,250 divided by 55, which looks intimidating, but we're going to take it one step at a time. Now the question is, how many times does 55 go into 5 without going over? It doesn't. 5's too small. How many times does 55 go into 52? It doesn't. 52's too small. How many times does 55 go into 522 without going over? Well, 55 times 10 would give you 550. So if we do 55 times 9, that should get us pretty close to 522. So let's do that off to the side. 5 times 9, as we saw earlier, is going to be 45. So we're going to put a 5 there and bring up a 4. 5 times 9 is 45. Plus 4 is going to be 49. So we know that 55 times 9 will give us 495. Let's subtract. 2 minus 5 we can't do, so we're going to have to borrow. In this case, we're going to borrow right here. This is going to become 1. This is going to become 12. 12 minus 5 is going to be 5. It's going to be 7. Okay. 1 minus 9 we can't do. We're going to have to borrow. This is going to become 4. This is going to become 11. 11 minus 9 is going to be 2. 9, 10, 11. Let's drop down this 5 and drop down this 0. Now the question is, how many times does 55 go into 275? And if it goes into 275 evenly, we know 55 will go into 2,750 evenly by tacking on an additional 0. Let's think about this. 50 times 2 will give you 100. 50 times 4 will give you 200. 50 times 5 would give you 250. So I'm going to say 55 times 5 will get us close to 275. So 55 times 5. 5 times 5 is 25. Carry the 2. 5 times 5 is 25, plus 2 is 27. So we can see 55 goes into 275 evenly. So if we tack on a 0 here, we know that 55 times 50 will be 2,750. Therefore, we'll have no remainder for this one. In other words, B is going to be, this one's going to be 950. Let's rewrite this so the variable's over here. In other words, this says that you're going to have to sell at least 950 bags of dog food to have a profit of at least $5,225. So to answer this question, it's a minimum of 950 bags of dog food. So not too difficult there. Number 6 says Ryan is a wrestler trying to make weight. He currently weighs 200 pounds. If he cuts 2 pounds per week, how many weeks will it take him to weigh less than 175 pounds? Again, in this case, we want to know when he's going to weigh less than 175 pounds. He doesn't want to equal 175 pounds. So we know we're going to work with less than or greater than as our inequality sign. That said, we want to write an equation or an inequality to represent this scenario. So we have, he weighs 200 and he's cutting 2 pounds per week, and we'll call pounds P to represent pounds. So that's the right-hand side of the equation. Let's put a box here to figure out what inequality we're going to put in there. And again, he wants to weigh less than 175 pounds. Again, this represents his weight that he's cutting, and he wants this to be less than 175 pounds. Okay? So with that, with those two things done, let's go ahead and solve this. Again, let's just rewrite it without that box there. Okay, again, we're solving for p in this case. So the first thing we're going to do is subtract 200 from both sides. That crosses out, which leaves us with 175 minus 200, which is negative 25. Again, this is greater than negative 2p. Again, we're trying to get 2p by itself, or p by itself. So we're going to subtract both sides by negative 2. And since we divide it across the inequality by a negative, that's going to prompt us to change its direction. This, of course, crosses out, leaving us with just p. And now we have negative 25 divided by negative 2. A negative divided by a negative is going to be a positive. But that said, we're going to do 25 divided by 2. Many of you can say that's 12 and a half without doing this long division, which is great, but I'll show you the long division just for practice. 2 goes into 2 one time without going over. 2 times 1 is 2. So we're going to subtract 2 minus 2 is 0. We have to drop down this 5. 2 goes into 5 2 times without going over. 2 times 2 is 4. Subtract 5 minus 4 is 1. 2 doesn't go into 1, so we have to add a 0. In doing so, that's going to prompt us to add a decimal. 2 goes into 10. Of course, 5 times 2 is 10, so we can see there's no remainder. So this is 12.5. Let's write it such that the variables on the left, p greater than 12.5. So in other words, it's going to take him more than 12 and a half weeks to weigh less than 175 pounds. Okay, so that's this one. Finally, we have the last problem in this video. It says Tom is deciding whether or not he should become a gym member to use their basketball courts. The membership cost is $135. Members must pay $2 to rent out the basketball courts. Non-members can rent the court also, but they have to pay $11 each time. How many times would Tom need to rent the court in order for it to be cheaper to be a member than a non-member? Okay. So in this case, again, we're not interested in those two things breaking even. So we know we're going to either be using greater than or less than. That said, let's start by writing the right-hand side of our equation. Again, to be a member, it costs $135. And to rent the court, it costs $2 each time. So we'll represent that as 2R to represent the number of times to rent the court. So we're going to let the rental fee correspond to the variable R. And he wants, we're going to put our box down to figure out what inequality we're going to use. And we're also told, in addition, it costs 11R to rent the court each time. Again, R refers to the cost to rent, the number of times you rent the court. So now we have our equation written. That said, he wants his membership plus the number of times he rents the court to be less than just renting the basketball court. So we're going to use that inequality there. Now it's just a matter of solving this for R, in which case I'm going to subtract. Let's start by rewriting this without the box. Again, we have 11R greater than 135 plus 2R. We're going to start this one by subtracting 2R from both sides. This is going to cross out, leaving us with just 135 on this side. 11R minus 2R. 11 minus 2 is 9R. Let's divide both sides by 9 to get R by itself. Again, we're going to have to do some long division here. So we have r is greater than 135 divided by 9. Let's work that out. It's not too difficult. 9 goes into 1. It doesn't. It's too big. 9 goes into 13 one time without going over, insofar as 9 times 1 is just 9. Let's subtract. 13 minus 9 is 4. We'll drop down this 5. 9 times 5 is 45. So we can see there's going to be no remainder there. So we know that r is going to be greater than 15. In other words, Tom needs to rent the court more than 15 times in order for the cost of his membership plus the $2 to rent the court each time to be less than just renting the court by itself. And that's the answer for that one. Here's all the answers. Admittedly, this video was, the problems in this video were pretty challenging. That said, this video was a good review as to a lot of the things you'll see on the actual ASVAB, namely multiplication and division with fractions, and as well as addition, subtraction, multiplication, and division with decimals. So it was a good review of those concepts. Regardless, I hope you found this video helpful in some way. If you like the content that I'm posting, by all means, please consider subscribing to my channel, as well as leaving some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. こんにちは。